Hello everyone, I am Mr. Sagar Bhopale, working as an assistant professor in Department of ENTC of AISSMS IOIT Pune. In this video, I am going to tell you something about time variant and time invariant systems. So, what is the definition of time variant and time invariant systems? And we will see the mathematical problems to check whether the system is time variant or invariant. So what is the definition of time variant and time invariant systems? So time invariant systems, if the time shift in the input signal results in corresponding time shift in the output, then that system will be called as time invariant systems. So let y of t is the response for x of t. So x of t is input, it is applied to the system and it will give the output y of t. Then if x of t is delayed by time t1, that is, if we make the changes in the input, then output y of t will also be delayed by the same time, that is, we will get the output y of t minus t1. So if we make the changes in the input x of t minus t1, that is, if we delay the input by time t1, and if we apply that delayed input to the system, then if we get the delayed output, then we can say that the system is time invariant system. So if we make the changes in the input, that is x of t minus t1, then if we get the output y of t minus t1, then that system will be called as time invariant system. For example, y of t is equal to x of 2t. So in this one, we can say that this is time invariant system. And if this condition is not satisfied, then the system will be called as time variant system. Example of it is y of t is equal to t into x of t. So it is example of time variant system. Now we will see the procedure to check time invariance. So the procedure for checking time invariance of any mathematical expression is same. So first we have to delay the input signal by m units of time and determine the response of the system for this delayed input signal. So let this response be y1t. Then second step is we have to delay the response of the system for unshifted input by m units of time and let this response be y2t. Then next, if we have to compare y1t and y2t, and if y1t is equal to y2t, then the system is called as time invariant system. And if y1t is not equal to y2t, then that system will be called as time variant system. Now we will see these steps diagrammatically. So first we have to apply the input to the delay block and we will get the delayed input. And that delayed input we have to apply to the system so that we will get the response for delayed input. So the input is denoted by x of t. It is given to the delay block and we will get delayed input. It is denoted by x of t minus m. That x of t minus m we have to apply it to the system so that whatever output of the system is there, we will denote it by y1t. So this is first step. Next, in the next step, first we have to apply the input signal to the system and then that output we have to apply it to the delay block. So input is x of t, it is applied to the system and it will give the output y of t, that is response for undelayed input, and that y of t we have to apply it to the delay block and whatever output of delay block is there we will denote it by y2t. And now we have to check whether y1t is equal to y2t, and if they are equal then that system will be called as time invariant system. Otherwise the system will be called as time variant system. Now we will see some problems to check the time invariance of the system. So y of t is equal to 2t x of t. So we will use the same steps which we have discussed in the previous slide. First, input is x of t. First, it is applied to the delay so that it will give the output x of t minus m. And that delayed input x of t minus m is applied to the system and it will give the output y1t. And it is equal to 2t x of t minus m. So this equation we will get from the equation which is given in the problem. So that y1t is equal to 2t x of t minus m. Now, next step is we have to apply the input x of t first to the system. So if we apply the x of t to the system, it will give the response that is y of t, and it is equal to 2t x of t. And that 2t x of t, we have to apply it to the delay block so that we will get y2t. So y2t is equal to 2t minus m x of t minus m. So it is, we can say that delayed response. And now if we compare y1t and y2t, we can observe that they are not equal. And as y1t is not equal to y2t, therefore the system is time variant system. Here we have to make one note that if we apply system to the input signal, then we have to make the changes in the x of t terms only. And if we apply the input to the delay block, then we have to make the changes in all the t's. Here we can observe that we have made the changes in all the t's. Therefore, here we have got the result that y1t is not equal to y2t. Therefore, the system is time variant system. Now we will see another problem. Y of t is equal to x of t plus dx of t by dt. So the steps will be same. X of t is first applied to the delay block, so it will give the delayed input, that is x of t minus m. So that x of t minus m is applied to the system. Now we will get y1t, and it is equal to x of t minus m plus dx of t minus m by dt. So this equation we have got from the problem which is given. Then next step, for now in the next step, first we have to apply the input to the system, and then we have to apply it to the delay block. So input x of t is applied to the system, so it will give the output y of t, and it is equal to x of t plus dx of t by dt. Now that output is applied to the delay block, so that we will get output y2t, and it is equal to x of t minus m plus dx of t minus m by dt. Now if we observe y1t and y2t, then y1t is equal to y2t. Therefore the system is time variant system. So in this way we can solve any mathematical problem to check whether the system is time variant or time invariant system. So for making this video, I have used this reference. Thank you.